Okay, so we are continuing 6.6, solving rational equations. Later on, we will go back to 6.5, which is complex fractions or complex rational expressions. Okay, but we will continue with 6.6 first. All right, let's see. So file, open, which one? Math 115? Okay. So this is what we did yesterday. So when we solve equations containing rational expressions, we have to check, yeah, whether or not these answers make the denominator 0, right? So why is this 5 not a solution? Because it makes one of the denominator 0. Okay. So now let's do an easier one. Let's see. This is one of the hardest ones. Okay. So number 2. All right. So proportion 4 over a is equal to 1 over 5. So then this one you remember, right? What do we call this type of equation? Proportion. Yes. When we have, what is a proportion? It's a statement that two ratios are equal. So this is a ratio. This is also a ratio. A proportion is a statement that two ratios are equal. So in this case, we could cross multiply. So we can cross multiply proportion. So a times 1 is a. 4 times 5 is 20. Now I need to check. A equals 20. Does it make the denominator 0? Yes or no? If I put 20 here, is this 0? No. So this is a solution. So whenever we have any denominator, we need to check to make sure the denominator is not equal to 0. So we have one solution, which is 20. Yeah, so proportion we can cross multiply. All right. Now, number 3. This is also easy. 5 over y plus 1 is equal to 4 over y plus 2. Why don't you try this one? Yeah. Number 4. 3 over x plus 2 is equal to half. Number 5, this is probably a little bit difficult compared to the other ones. X over x minus 5 plus 1 over 5 is equal to 5 over x minus 5. All right. And then number 6, which is a little bit longer. Okay. 3x over x minus 4 is equal to 2x over x minus 3 plus 6 over x squared minus 7x plus 12. Okay. All right, so number 3, is it a proportion? Yes or no? So is number 3 a proportion? Yes. So you could cross multiply. How about number 4? Is it a proportion? No, so this is not a ratio equals to not ratio, so we have to, what do we have to do here? We have to multiply by the LCD. What for number 4, what is the LCD? 2 what? 2x. Yes. So for number 4, the LCD is 2x. So we will multiply both sides by the LCD. Now let's look at number 5. What is the LCD for number 5? This is not a proportion either. So what is the LCD? X minus 5 times 5. So remember, it's all the distinct factors. So it's 5 times x minus 5. Yeah. How about number 6? What is the LCD? What is the LCD for number 6? X minus 4 times x minus 3. Okay? Can you work on those? I will give you back your pen. Oh, you left something? All right. Good. Okay, let me return your pen. So, can you guys work on this while waiting for me? So Daisy, James, Jennifer, Andrea, Guadalupe. So Daisy, fantastic. Jennifer, Andrea, Guadalupe, great. James, good. Rainier, oh, he's not here. All Rainier. All right. Nicholas, Martin, Sergio, Celine, Dominic. Sergio. Oh, one of the highest. Martin, one of the highest. That's good. Celine and Dominic. Hold on, I have your old stuff. I think Dominic, this is your homework. Previous homework. What else? Celine, you have your test, right? Yes. Your old test. I gave it to you. Yes. Yes. Okay. Sorry. No, there's one more. I think so. I gave it to you? Oh, here. Maribel, Cecilia, Esmeralda, Jasmine. Oh, very good. Cecilia has 100. Esmeralda. Jasmine's not here. Noemi, Estefani, Jennifer Munoz, Cesar, Jennifer Reyes. Jennifer, very good. Estefani, hold on, I have your old. Okay. Yeah, Jennifer Reyes, very good. Cesar, Miriam, Hema, Hugo, Clarissa. Miriam? Yeah. Hema, good. Hugo. Oh, Hugo, one more. Actually, two more. Clarissa, good. Lily, Javier, Myra. Lily, Wait, this is your homework. And Myra is not here? Alright. So Melvin, this is yours. Oh, Lily, there is your homework also. Alright. Okay. So can you look at it really quick? Did I grade them correctly or not? A lot of people did really well. The highest score is 100, and there are a lot of 90s. Yeah, 97, 98, 94, 95, 96. Yeah, so a lot. So you think the test was better? I mean, easier? Very important, factory. Yeah. So 2 minutes. You can look at them. I actually have your average also, but I didn't download the quizzes or the homework. Yeah, so Tuesday I will download, so whatever your average, I will let you know on Wednesday. So Wednesday we have a test, right? Okay. So I will download the homework and quizzes on Tuesday night, and then let you know on Wednesday. But it may change, because why? Your homework is and your quizzes are due when? Sunday. Yeah. Well, they were due, but I reopened them till Sunday. Not the homework, only the quizzes. Yeah, so you could still do the old homework up to Sunday. Yes, did I say that already? Yeah. Okay. So it's clear, is it? So the late homework, whatever homework that you haven't done before, you could still turn in up to Sunday. It's just that you will have a 10% penalty. That's all. Yeah. All right, so now number 3. What are we supposed to do here? Let's do it fast. So we could finish 6.5 and start 6.7. So what is it? We cross multiply. Is this a portion? Yes, this is 2 ratios are equal, so we can cross multiply. Or you could say, oh, the LCD is y plus 1 times y plus 2. You can multiply both sides by y plus 1 times y plus 2. Or we could cross multiply, so 5 times y plus 2 is equal to 4 times y plus 1. So 5y plus 10 is equal to 4y plus 4, right? Okay, so now bring the y to the left. 5y, this 4y will be what? Negative 4y. Right? So we subtract 4y both sides. How about this 10? It will be what? Negative 10 plus 4. So 5y minus 4y, y is equal to negative 6. Now, is negative 6 a solution? How do you check if it is a solution or not? We just substitute to the denominator. Negative 6 plus 1, is it 0 or not? Is negative 6 plus 1 0? No. It's negative 6 plus 2 0? No. So yes, this is a solution. So we do not want denominator to equal to 0. Okay? Okay, good. Next, number 4. Is this a proportion? No. Why not? Well, I have 2 terms here. This is not a ratio. A proportion has to be ratio equals to another ratio, and this is not. This is not a ratio, so this is not a proportion. Now, this is easier. We do not have to carry the LCD. However, we will multiply by the LCD both sides. What is the LCD? Least common denominator, which is? Yes, x times 2. Yeah? So we will multiply both sides by 2x. So multiply each term by 2x. Remember, the 2 you have to multiply also by 2x. So you can't just pick and choose, oh, I want to multiply these by 2x. Oh, I don't want to multiply these. No, each term must be multiplied by 2x. Okay, so now the x cancel here. What am I left with? 6 plus 2x times 2, that is 4x. Now the 2 cancel, so I will still have x. Alright. Then what? Subtract 4x both sides? Okay. So 6 is equal to negative 3x. So what is x equals to? Negative 2. Okay. Now, is negative 2 a solution? How do you check if it is a solution or not? Substitute to where? To the x here on the bottom? Yes. We just need to make sure it's not 0. So if I substitute negative 2 here, will it make it 0? No. So yes, this is a solution. Alright, so the solution is negative 2. Right? Okay. Yes, so far so good? Alright, now let's continue. So here we cannot do cross multiply. Why? Just simply because it's not a proportion. Now number 5. Alright. Is it a proportion? No, well, this is not a ratio. Well, the right side is a ratio. This one is not, the left side. So we have to multiply by the LCD to clear the fractions. So what is the LCD? X minus 5 times 5. What about these x minus 5? Oh, we already wrote it. So we write LCD is x minus 5. That's one distinct factor. Multiply by 5. And then this x minus 5 we already did. Yeah. So now we will multiply both sides by 5 times x minus 5. So here we multiply by 5 times x minus 5. 5 times x minus 5. 5 times x minus 5. So each term is multiplied by the LCD. Now I could do this because this is an equation. So both sides multiplied by the LCD. So only if we have equations. So which one cancel? X minus 5. And here, the 5 cancel. Here, x minus 5 cancel. Okay. So what are we left with after we cancel out x minus 5? 5 times x minus 5. What are we left with here? 5x plus x minus 5 is equal to 25. All right. So 6x minus 5 is equal to 25. Okay, then what? Yes, we add 5 to both sides. I think I'm going to cut these. Okay, so and paste it there. Edit. Okay. All right. So 6x is equal to 30. Because we're adding 5 to both sides. So what is x? 5. Yes, but is 5 a solution or not? Why not a solution? Yes, it makes the denominator 0. Yeah, so what is your solution? No solution. So how do you write no solution? Or you can just write it as an empty set. So this is an empty set. this is the same thing as this. Yeah, so no solution, an empty set. Okay, so this is the two symbols for empty sets. So the symbol is either this or this. All right? Okay, so let's continue. Number 6. Is it okay so far? Can you tell this between this expression and, for example, this expression? 5x over x minus 5 plus 1 over 5. What would you do if this were addition? Common denominator, what is the LCD? 5 times x minus 5. So you have to rewrite these, right? Oh. Remember? So there is a difference. So if you're adding, which is section 6.4, you see that we have to carry the denominator. We have to carry the common denominator. Yeah, so there is a difference. Here what happens, this is easier. Why? Because we could cross out the denominator. So do you see it? Then I have to write it like this. Oh, it's missing 5, so I have to multiply by 5. So this is 25x. Remember? Now it's missing x minus 5, so I have to multiply both sides by x minus 5. So this is x minus 5. So this is adding. What are we doing here? We are solving for x. This is an equation. So all the things here that we have, this is an equation. This is an equation. Yeah. But here, this is an expression. So we have to continue here. What is this? Common denominator, which is 5 times x minus 5. And then what do you have on top? 25x plus x minus 5, isn't it? So this is 26x minus 5 over 5 times x minus 5. So this is if you are adding. We cannot clear the denominator. You see? When we solve, we could multiply the LCD to both sides. That's why we could clear the denominator. I just need to make sure you know the difference between these two. So this is 6.4. The ones that we were doing, number 1 through 5, were section 6.6. Yes, can I clarify anything before we move on so everybody knows the difference between adding and solving equations? Yeah, so what happened? If you have equations, we have both sides. So we could clear the LCD, the denominator. Yes? Okay. Now let's continue. So tell me, is this an equation or an expression? Equation, so can I clear the denominator? Yes, I can. So this is an equation. How do you know it's an equation? Well, it's simple. It has two sides. Yeah. Okay. So now, if I factor out x squared minus 7x plus 12, what will this be? So factor out x squared minus 7x plus 12. So it is x minus 3 times x minus 4. Yes. Right? Okay. So actually, this one, if we write, this is 3x over x minus 4 is equal to 2x over x minus 3 plus 6 over x minus 3 x minus 4. All right. So what is the LCD? Yes, x minus 3, x minus 4. Yes, you're right. So this is the LCD. So what do I do with my LCD? Multiply both sides by the LCD. Yes. So x minus 3 times x minus 4. X minus 3 times x minus 4. x minus 3 times x minus 4. So this is an equation. I could multiply both sides by the LCD. Okay, so now what? X minus 4 cancel here. X minus 3 cancel here. And both x minus 3 and x minus 4 cancel. Let's see, what do we have here? 3x squared minus 9x. Or if you want, you can write it first. This is 3x times x minus 3. No problem. This is 2x times x minus 4 plus 6. Then you can distribute. What is this? 2x squared minus 8x plus 6. Okay. Now what? This is what type of equation? Linear? Is it linear? Yes? What is it? What type of equation is this? What is this called? What type of equation is this? Quadratic, that's right. It's a quadratic equation. Why is it called quadratic? Because we have a square. The highest exponent for the variable is squared. So this is quadratic. So quadratic, we have to set it to standard form. Now, bring everything to the left. Yes, so subtract 2x squared both sides. That's quadratic. We have to change it to standard form. Plus 8x both sides. Okay? And then minus 6 both sides. Alright. So what is my answer here? 3x squared minus 2x squared. That is x squared. Negative 9x plus 8x. Negative x minus 6 is equal to 0. Okay. Is it factorable? What is this? X minus 3 times x plus 2 is 0. So what is x equals to? 3, or x is equal to negative 2. Yeah. So x minus 3 is 0, so x is equal to 3. X plus 2 is 0, so x is equal to negative 2. Are both solutions? Which one? Is 3 a solution? Yes or no? X equals 3. Is 3 a solution? No, why not? 3 minus 3 is 0. So this is not a solution. Yeah. How about your negative 2? Is negative 2 a solution? So let's see. In negative 2 minus 4, is it 0? No. Negative 2 minus 3, is it 0? No. So negative 2 is a solution. Alright. So we have only one solution, which is negative 2. So what is this then? This is called extraneous solution. Yeah, which is not a solution. Yeah, it's not a solution. Okay, good. Now, we'll do 2 more problems, and then I will give you a quiz on this section, 6.6. Yeah, let's do 2 more. And then we could start 6.5. Okay, or let's do 1 more, and then we have a quiz. Let's see, quiz 6. All right. Here. This is 6.6. Okay. Okay, here. All right. Number 1. Oh, number 7. Yeah. Okay, let's see. Oh, I have it here. 2k over k plus 7 minus 1 is equal to 1 over k squared plus 10k plus 21 plus k over k plus 3. K plus 3. So let's rewrite this. 2k over k plus 7 minus 1 is equal to, factor out the k squared plus 10k plus 21. How do we factor out k squared plus 10k plus 21? Yes, k plus 7, k plus 3. Yes, plus k over 3. So, do we know the LCD? What is the LCD? LCD is what? K plus 7. What's the highest exponent for k plus 7? Just 1. Yeah. K plus 3. What is the highest exponent for k plus 3? Just 1, which is nothing. We don't write highest exponent unless we have a square here. Then we include the square. So we will multiply both sides by the LCD, which is k plus 7, k plus 3. The negative 1 we also multiply by k plus 7, k plus 3. This one also k plus 7, k plus 3. And the last part also k plus 7, k plus 3. So Eric, you have 2 more minutes. Yeah. K plus 3. All right. Good. So let's see which one cancel here. Oh, the k plus 7 cancels. These ones, k plus 7 and k plus 3 both cancel. On this one, oh, the k plus 3, oh, where is it? Cancel. All right. So let's see, what do we have? So 2k times k plus 3 minus 1 times k plus 7, k plus 3 equals to 1 plus k times k plus 7. Are you done or no?
Yes.
Okay, good. So see you tomorrow.
So I can my homework
Yes, today.
today.
Yeah. All right. So let's see. What is this? 2k times k, 2k squared plus 6k. Now be careful. This is a potential error here, because I have a negative. So I have to distribute my negative. Negative. Let's multiply here. K7 times k plus 3. We have k squared plus 10k plus 21. So remember, this is the negative sign. This is a potential error. Is equal to 1 plus k squared plus 7k. All right. So let's distribute. 2k squared plus 6k minus k squared minus 10k minus 21 is equal to 1 plus k squared plus 7k. Okay, then what? Combine like terms. So 2k squared minus k squared, that is k squared. 6k minus 7k, minus 4k, and then minus 21 is equal to k squared plus 7k plus 1. Alright, you have to put your name here. Do you have a name? Oh, no, why did I give you this? I'm supposed to read it, right? Okay. It's minus. Okay, I'll see you tomorrow. Alright, so now what are we going to do? What are we going to do here? Yes? What are we going to do? Yeah, so when we subtract k squared, what happened? Cancel, right? So I have k, this is linear because the k squared cancels. So before this is quadratic. Linear means the highest exponent is 1. Yeah. So if linear, one variable on one side, number on the other side, so we have to bring the k to the left. So what do I have here? Minus 7k is equal to, what happens to this negative 21? Go to the other side. So this is negative 20, no, becomes positive 21 plus 1. Alright. So negative 11k is equal to 22. Yes. So what is k? Negative 2. Is it a solution? Yes or no? Solution? Okay. So yes, this is a solution. So your solution is negative 2. Alright. Doable? Okay. Now, let me ask you, do you want to have a quiz or do you want to start section 5.5? I mean, sorry, 6.5. So tomorrow we have a quiz if we have time? Okay, so tomorrow we have a quiz 6.6. Yeah, okay, so let's start 6.5. All right. So let's start. Okay, so we're done with 6.5. So we're done with solving rational equations. We will start 6.5, which is complex rational expression. Okay, so 6.5 is complex rational expression. Okay. So disclaimer, this looks hard, but it's actually not hard. It looks complicated, that's why it is called complex rational expressions, but actually it's not, it's easy. Yeah, so let's start. All right. So 6.5. Complex rational expression. So this is an expression, not equation. So equation is 6.6. Okay. Now let's see. Okay. Okay, so examples of complex rational expressions. Complex rational expressions. So why is it called complex anyway? Because the denominator or numerator contains another fraction. So, for example, it looks like this. X over x minus 3 divided by 4 over 5x minus 15. Alright. Another example is 1 plus 1/3 divided by 5 minus 5 over 27. Okay? Alright. Now, what is the best way to solve these? This one looks hard, isn't it? You see, it looks complex. So it has a numerator and denominator on top and also on the bottom. Yeah. But, yes. So there are two methods to solve these, and both are not too hard. So once you apply the method, you'll see, oh, that's easy. Yeah. So in this case, method 1, this is good. So use, what do I do? What do I do in method 1? Rewrite division as what? Yes. As multiplication with the reciprocal. So that's what we always do anyway. So now, yeah. So instead of writing this as division, I'm going to write this as multiplication. Right? Now, when can you use it, or when is it easy to use? So this is easier if both numerator and denominator consist, I should say each of numerators, not each numerator and denominator consists of one term. Yeah? So what do I mean? Look at the numerator here. How many terms is this? How many terms? This is only one term. Yeah? So this is one term. How about this? How many terms is this? How many terms? 2 terms. Right? So how many terms is this? How many terms? 1 term. Is everybody clear why this is 1 term and this is 2 terms? Why is this 2 terms? Well, because you have 2 different terms separated by a plus or a minus. Look at this. Is this separated? Not really. How about this? Well, yeah, I have a minus, but that's on the denominator. But altogether, this is consider 1 term. Yeah. How about this? How many terms is this? 2 terms. Yeah. So anyway, this method 1 is easier to use if each consists of 1 term. So it's good for number 1 and more difficult for number 2. For number 2, we will use method 2. Yeah. So if any one of denominator or numerator consists of more than 1 term, then we will use method 2. We could use method 1 only if maximum is 1 term on top or the bottom. Consists of a maximum of 1 term. Okay? Alright. So now I'm going to write this number 1. So this is x over x minus 3 divided by 4 over 5x minus 15. This is what? How do I rewrite this as multiplication? This is x over x minus 3. Instead of division, I will change this to multiplication with the reciprocal. So what is the reciprocal of 4 over 5x minus 15? Yes, 5x minus 15 divided by 4. So is it easy now? Yes, it is. Yeah, so it just looks scary, it just looks complex, but it's actually not. Yeah, so this is one term and one term, so use method 1. Okay? Now, so let's do this. This is the reciprocal of 4 over 5x minus 15. This is just the note. You don't have to write this. Yeah, so this is multiplication with the reciprocal of 4 over 5x minus 15. So now, how do we proceed, given this is what we have? So x over x minus 3, what are we going to do here? Factor, yes, we know how to do this. 5 times x minus 3 over 4. Okay. Now what? What is it? Cross cancel? Common factor? Yes. So this is not cross multiply. Okay? This is cross cancel. Yeah? Cross multiply if you have a proportion. So A over B is equal to C over D. Then we cross multiply. Look at this. This is equal sign. This is proportion. So AD is equal to BC. This is cross multiply. This is cross cancel. This is not multiplication. So what do I have on top? 5x over 4. Is it easy? Well, yeah, right? Not too bad. It just looks hard. Now, when do you use method 1? When is it easiest to use method 1? When the top or the bottom consists of a maximum of one term. Yeah. So do another example. Let me see. 6.5. All right. How about this? 8 minus x divided by 10x over 16 plus 7x squared over 2x squared. All right. Now, let me ask you, how many terms is this? 1. It is considered one term. How many terms is this? No, it's considered one term, right? Because it has the same denominator. Yeah. So look at these. They have common denominator, doesn't it? If I write 16 plus 2x, this is 16 over 3 and 2x plus 7, then this is 2 term. But this is considered one term here. Yeah. All right. So this is considered one term, and this is considered one term. So we use which method? Method 1. All right. So we will multiply by, we will write it as multiplication. So 8 minus x over and x, and then multiply by what? 2x squared over 16 plus 7x squared. All right. Okay, so any common factor that we could cancel? No? Which one? How about this is x squared and this is x and this is 2 and this is 10? Can I cancel 2 and 10? Yes, it becomes 5. Good. How about the x squared and x? X squared divided by x is x on top. Yes, good. Almost done. So what do I have left on top? X times 8 minus x. So do we multiply them? No, we leave them in factored form. Divided by, what is this? 5 times 16 plus 17x squared. Yes? Okay. What happened? Oh, it's only 7, right? How do I get 17? I don't know either. It should be 7. Thank you. Yes, you're right. 16 plus 7x squared. Yeah, good. Yes? Can I move on to method 2 now? So what happens if I have two terms like this? Look at these. You have two different terms. They do not have common denominator. Yeah? So let's write down method 2. So method 1 is only for one term. Well, they have one denominator here and one denominator here, so this is considered one term. Yeah? The denominator is the same. So method 2. Yes. So method 2. So method 2, this is for any, but so what do we do here? We find the LCD of all the numerators and denominators. So all the LCD, okay, not the numerator by itself, denominator by itself. No, it is all together. What is the LCD of the LCD of the numerator and the LCD of the denominator? So multiply by the numerator, the expression by 1. i.e., so 1 is the multiply both the numerator and denominator by the LCD. Alright, so that's method 2. So, and then let's see, this is easier if the denominator or numerator consists of more than one term. So if any one of them consists more than one term, then it's easier to use method 2. So what problem did I write before? So this one, right? 1 plus 1/3 divided by 5, is it minus 5 over 27? Okay. And then let's do one more. 5 over a plus, 5 over 2a plus 1 over a divided by 1 over 4a minus 5 over 6. Well, they just look complex, but actually it's doable. All right. Tell me what we're going to do. Which one is denominator here? Which one is denominator on top? For the numerator, the denominator is 3. Okay. For the denominator is 27. So 3 and 27, what is the LCD? What is the LCD of 1 over 3 and 5 over 27? So, what is the LCD of 1/3 and 5 over 27? Come on, you guys know this. 27? Is it? Does everybody know it is 27? Yes? Okay. So, 27. Yeah. So, what we're going to do is multiply each one of them by 27. So the top I will multiply by 27. And the bottom I will multiply by 27. So it's practically, I'm practically multiplying the top and the bottom by 1. 27 over 27 is 1. Okay. So now I could write them separately. So like this. So 1 plus 1/3 divided by 5 minus 5 over 27. So I'm going to multiply each one of them by 27. So multiply these by 27. All right. So what do we have? Well, this one cancels. So 27 divided by 3? 9. 27 divided by 27? Cancel. Okay. All right. So what do I have on top? 27 times 1? 27 plus 9. Okay. Now, what is the denominator? Over 1. Well, we don't write over 1. What about this? 27 times 5? 135 minus 5. Okay. So this is 36 divided by 130. Yeah. Make it smaller. What is this? Don't change it to decimal. Yeah. So divide by 2. Is it 18 over 65? Yes. All right. Okay. Yes, so far so good? Okay. Can we finish one more? So it's not as complex as it looks, right? All right. Now, number 2. What is the LCD? So you have 2A, 4A, and 6. So A, I know A will be on the LCD. So 2, 4, and 6. What is the LCD of 2, 4, and 6? 6. So does 6 is 6 divisible by 4? No. So what number is divisible by 2, 4, and 6? 12. So what is the LCD? What is it? 12 what? 12A. You're right. Yeah. So now I will multiply each one of the term by 12A. So I'm not going to write it like this because I think it is confusing. But you guys got the idea, right? I have to multiply the top by 12A and the bottom by 12A. So let's multiply by 12A. So 12A times 12A times 12A times 12A. So that's the LCD. So we multiply each term by the LCD. Alright, so let's see. Some of them cancel. 12A divided by 2A, 6. A cancel. And then 12A divided by 4A, 3. And this is 12 divided by 6 is 2. Alright, almost done. So what do I have on top? 6 times 5, which is 30, plus 12. isn't it? Because the a cancels. So you have 1 times 12. Divided by, let's see what cancels on the bottom. Oh, so it becomes 3 times 1, which is 3. And what about this? 12a plus 10? Or minus 10a? Minus 10a. All right. So what is 30 plus 12? Am I missing the a here or no? No, I don't. So 42 divided by 3 minus 10a. All right. Can I factor out anything from 3 minus 10a? No, so we're done. Yeah, so see, your fraction is not complex anymore, right? Yeah. Which one do you prefer, method 1 or method 2? 1 you could rewrite, but it's harder if you use method 1 on these number 1 and 2. Yeah, so sometimes it's easier to use method 1, sometimes it's easier to use method 2. Alright? Okay, so tomorrow we will do more examples on 6.5, and we will also discuss some word problems. So from 6.7. I didn't assign 6.7, did I? On the homework? Or maybe just finish here. Yeah, so what do we do? Because on chapter 6 exams I have word problems, so maybe I'll just ignore the word problems on chapter 6 exam. So that's it. We're done with all the materials for the class. So tomorrow, please bring with sample test for chapter 6, right? And we will do more on 6.5, and we will have a quiz on 6.6. Okay? All right. Okay, guys. See you tomorrow. So remember to come tomorrow. Yeah, we have a quiz. 6.6. Yes? Yeah. When's our final? Is it Thursday? So you want to take it on Tuesday? Yes. Okay, Tuesday, 9:30 to 11:30. Yes. Yes. Yeah. Can you remind me next week? I mean, by Friday or Thursday? Yeah, remind me on Thursday. Okay. Why? Oh, okay. But Tuesday is fine, right? Yeah, fine. Yeah, Tuesday. Okay, so Tuesday. Okay. Yes. Okay. Hold on. Let me close the recording. I forgot. All right. So we're almost done with complex rational expressions. Tomorrow we will just do examples. So see you tomorrow.